So step 1 is calculate maintenance rate. And this would be for every animal that was going to be hospitalized, right? Yeah. So maintenance rate, as if I remember, is 60 milliliters per kilogram per day. All right, that's step 1. Step 2, calculate rehydration. All right, and my equation is percent dehydrated times kilograms times 1,000. And with this one, you do have to memorize it, but really, if you think about it, if we look at each piece and remember why it's there, it's going to help you remember it, okay? So the weight of the patient. Well, yeah, duh. I need to know the weight of the patient for anything I'm going to give a patient, right? If I'm going to give them drugs, if I'm going to give them fluids, I always need to know their weight. Okay. Percent dehydration. So percent dehydration, when we say a patient is 8% dehydrated, we're talking about their overall fluid in their body, right? So it is dependent on their weight, right? So 8% dehydrated on a big Great Dane might equal like, I don't know, like 20 kilograms, let's just say, right? But 8 of fluid. But 8% on a Chihuahua is like 2 kilograms of fluid, right? Weight of fluid. So I need to know, and this is the rehydration, right? So it makes sense that I would need to know how dehydrated they are. Okay. The 1,000 we know is because this answer mathematically comes out in kilograms, or I'm sorry, it comes out. Sorry, I need water. Comes out in liters, and I don't want to work with liters. And then this information is here because I only want to rehydrate 80% of their deficit initially, right? Sure, okay. All right. So, step 3, are there any ongoing losses? And again, that's just going to be a number. That's just going to be like 100 milliliters a day. If there are, we'll add them in. So we take all that information, we add it all together for my total volume per day, which will be milliliters for the day. Okay? And the homework's going to kind of walk you through doing these steps. All right. The next step after that is going to be, well, we have to give the animal these fluids, right? We got to administer them in some way. So what are we going to do? Most frequently, you're going to use a pump. So I just got to figure out the pump rate from there, right? So, and if you haven't worked with these pump yet, you will very quickly learn that a pump rate is always going to be in the unit milliliters per hour. That's how these pumps are set up. Okay. I'm just now realizing I probably shouldn't have written all of this in red, but I'll go through and highlight the equation stuff. Color coded it a little bit better. Sorry. We'll calculate the pump rate. Then on the homework, it's going to say, oh no, when I was in Florida, I used to say that there was a hurricane and power went out because that happened all the time. And you're like, you may be like, yes, but Miss Stephanie, aren't those pumps battery powered? And I'm going to tell you, yes, they are battery powered. But one of the things that technicians and assistants are very bad about, and doctors, is making sure the pumps are plugged into charge at night. So you go and you grab a pump and you set it up, and it's the beginning of the day, and it immediately starts yelling at you that the battery is about to die and you have to plug it in. So this happens a lot. Or maybe you work shelter med and you guys can't afford a bunch of pumps. So you only have 1 or 2 pumps and then you have 5 patients. So we're going to need to do a drip rate. All right. And a drip rate is literally, you're looking at the viewfinder in that fluid line and you're counting the drops. What is drip rate? Does anyone remember, other than Nicole or Alex? or Tanya for that matter, because she's had practicum. Any of you other guys know what the unit is for a drip rate?
It's like GTT.
So yeah, so GTT is drips. Drips for what? For how long though?
Per minute.
Okay, so minutes okay, but when we're counting them, a lot of times you'll figure per minute first, but practically speaking, do you want to sit there and count the drops for a whole minute?
No. Is it per second?
Yeah. So you do figure it for minutes first, but it's actually best to get all the way down to seconds, because you have to count it a couple times. And if you were going to do it by minute, you'd have to sit there for 5 minutes just counting it, because you'd want to count it a few times to make sure it sits. So yeah, we don't normally have that kind of time. So good. Yeah, you got all on track. That's good. Yeah. So GTT is drips, and the rate we're going to get it down to is per second. And then there's a little trick we're going to do when it comes to that, because you're going to get some weird, funky decimal. So I'll make the note here so you have it. We have to round for a countable rate, and I'm going to show you guys how to do that. Or I'm going to not round. Let's just say get a countable rate. And what I mean by that is, if my answer comes out to 0.3578 drops per second, I don't think any of us can count a 0.3578 drop, right? We can't. You have to see a whole drop to count a drop. So we have to get it to whole numbers, essentially. I'll write that too. And that's a whole nother little thing we have to do. Okay. 6:14. Let's go ahead and take a 10-minute. We'll work through a problem. We'll work through the problem that's in the PowerPoint. So I've got 14, so 24. Okay, so let's go ahead and work through the problem that was on the PowerPoint. Okay, so we had a 14-pound patient that was 3% dehydrated with 100 milliliters per day of ongoing losses. So the extra step that's going to be in the homework is the assessing dehydration. So the first part of the homework problem is going to be, there's going to be history, there's going to be physical exam information. You're going to decide which range, right? But go ahead and pick one number. So then it's going to ask you, how dehydrated is this patient? It's also going to ask you, how dehydrated do you think the patient is based just off of the history? And remember, we're only going to assume a patient is dehydrated if they have a history of vomiting or diarrhea, or if they have a history of not eating or drinking. And then the maximum we can assume is always that less than 5%. And you can just write that. You don't need to pick a number. It's just less than 5. But we are saying they are dehydrated when we say that. So that's our slight range. And then you'll move on to the math part. Okay. So remember, with step 1, we're going to do maintenance. Okay. So we're going to, this is dimensional analysis. So like I said, I still do it to this day. I'm going to do my need and my have list over here, because that helps my brain. So I need, all of these are going to be in milliliters per day initially, right? So I need milliliters per day, and I have 14 pounds. I can write 3% if I want here. I'm not going to use it right now, but might as well. It's a puzzle piece. It's up there. And actually, I think I would probably write it, because this is percentages. I already told you doesn't work in dimensional analysis anyways. So I would go ahead and write this in decimal, which is 0.03, right? And then I'm looking for maintenance fluids. So I have to have my maintenance conversion, right? Per kg day. Okay. All right, let's do it. So I recommend working through this with me. All right, so we've got 14 pounds. That's gone. I want to use this piece, right? And it's got kilograms, so I know I can get to kilograms. I know I have a little trick, a little puzzle piece up my sleeve for that one. Okay, this guy's gone. Oh, I didn't have. I marked that off. I hadn't actually used it yet. My bad. We'll throw that one in now. Right, kilograms will stay on the bottom, so I want my 60 milliliters on top. Am I done? I don't know. Let's cancel. Pounds are gone. Kilograms are gone. I have milliliters over day. It's exactly what I'm supposed to have. Excellent. Remember, you want to do that before you can put it in your calculator, which I forgot to grab. Always have your calculator with you. All right. So anyone want to tell me what they got for the top?
381.82.
On top?
Oh, spirit. No, that's the whole thing.
Okay. Scared me for a second. Okay, yeah, so I got 840. And don't forget your unit, milliliters. And then, 2.2 day. And what was that final one, Alex?
381.82 mils per day.
Okay, yeah, and I would keep a few decimal points until you get to the end to your pump rate. Because remember, the more you round in the beginning, the less accurate your number is. So for now, go ahead and just keep some of those decimal points. So I'm going to do 8.2. Because it was 381.8181 repeating. So 381.82 milliliters per day. Don't forget your unit. Awesome. And I recommend as you do this, labeling it like this. When you label, and now the homework's kind of already labeled, but maybe just kind of have it in your brain because it's going to remind you of the steps. Because again, the homework is stepwise, but on the final exam, it's not going to be. It's just going to be, here's a patient, here's its presenting complaint, here's its physical exam. Tell me how dehydrated it is. Tell me total fluids for the day. So you're going to need to know maintenance plus rehydration plus ongoing losses, pump rate, and drip rate. Okay? You're going to have to know how to get through those steps yourself. Okay, so then we have, so our next step is to do rehydration. Okay, and for that I have my equation, right? So I know that I'm only going to use 80% of the total. I want to know the percentage of dehydration. Well, cool, I have it over here in my have, so that's good. 0.03. I want to know their weight in kilograms. So there's a couple things you can do here. It's up to you. You can go ahead and steal that information from right here. Or what I prefer to do, because it gives you a more accurate number, because you don't have to round early, is I actually put it in. Like that, right? So I do 14 divided by 2.2. But it's completely up to you. If you want to just put the kilograms in here, you can. I feel like you get a more accurate number this way. And then I want it to be in milliliters, not liters, which is what I'll end up getting if I don't multiply it by 1,000. That's it. Remember your order of operations, okay? So you're going to do this guy first, all right? Then you can multiply by both of these. And then lastly, you multiply by this because it's 80% of the total. If you multiply this too early, you end up taking 80% of one of the other ones. So remember your order of operations. So I'm going to go 14 divided by 2.2 equals times 0.03 times 1,000 times 0.8. Oops, crap. What do you guys get? Anybody get an answer yet?
I got 152.64.
Okay, cool. And that's funny because calculators are funny like that sometimes. Because I got 152.72 repeating. And again,
I got that too, 152 with 7.72 repeating.
Okay. And so Alex, did you figure out the kilograms and then take that number and throw it in? Oh, she just dropped off. Okay, that might have been what happened. And here's the thing, as long as you're close, I'm not going to mark it wrong because I do know that sometimes there's calculator error. And also, again, if you were to have taken 14 divided by 2.2 and then taken that number, My thought is, again, you're already in your calculator. You might as well leave it that way. But it's up to you. But if you do that, it will change it a little bit. So 152.7, and we'll say 3. And then remember, this one, people very frequently forget their unit because they didn't work with any units back here, okay? But remember, never, ever, in any medical math ever, are you ever not going to annotate what that number means. All right, just get that in your head now. Never, ever, ever should you ever write a number and not say what that number is, okay? So you always are going to put a unit with your medical math. All right, and so now I need total. So now I'm going to do my total volume. So remember, don't forget to go back and look. Were there any ongoing losses? And yep, there sure were. There were 100 milliliters per day. So I'll make sure I'll add that. I'm going to go ahead and put that one in first so I don't forget it. So I'm going to say 100 milliliters per day plus, I can grab this one, 152.73 milliliters per day plus, what's up? Oh my God, this thing keeps like freezing on me. Oh, can someone read me the maintenance number? My thing's stuck.
Maintenance was 381.82.
Thank you. Milliliters per day. Now I'll get my magic total. So 100 plus 152.73 plus 381.82. I got 634.55 milliliters per day. And again, I leave it there because I still got to get to my pump rate, right? Once you get to your pump rate, then you're going to have to round because you can't put, well, that's not true. You can put decimals in the pump, but only for really small numbers. Normally, you're going to round up to a big number. And then even if you can put decimals, you can only do one. So we will eventually have to round. But remember, you don't want to round until the very, very end when it's practical, when you actually have to use the number. Like when you calculate drugs, for instance, right? You want to keep all those numbers until you finally have to draw it up in a syringe because that's correct. You cannot draw up 0.893 of anything on a syringe. Okay. Oh man, this thing. I'm going to get out and come back in. See if it'll let me work then. All right, that's all it needed. Okay, so here's my answer for total volume for the day. All that for one answer. Cool. Okay. Now, again, practically, we have to go ahead and administer this. So I'm going to do a pump rate. And if I look up here to remind myself, I know that a pump rate is milliliters per hour. Okay, so that's what I need. So my need is milliliters per hour. My have is, what information do I need? Do I need to go up and get, do I need any of this stuff? I don't, right? I don't need to go backwards. Again, all this is kind of stepwise. I'm just going to use this one. I'm going to use that answer I just had. I don't need to go back and get weight and stuff. So 334.55 milliliters per day. Okay, that's the only info I have. So I'm going to start with that one. This one's really easy, right? Some of you guys are already like, oh, all you have to do is divide by 24. I know, but again, remember, we're just practicing our dimensional analysis, so you do need to write it out. But yeah, in real life, that's what you do. You just divide it by 24, right? And this is how I know that's true. I'm proving the math. It's a math proof. All right, see, yeah, so I wanted to get rid of the days, and I wanted to get to hours. So I just put days on top to make them go away. I end up with milliliters per hour. That's exactly what I want. That's excellent. So on top, I just have, I know it seems redundant because see, now we're just bringing everything over. But again, it's just about practice, making sure you know how to put it all together. All right, so that divided by 24 ends up equaling, we get 296.4. Ooh, no, go away. 0.44 milliliters per hour. So what I want you to do, ooh, that's crappy, sorry. What I want you to do for this math, once you get to the point where you actually have to use it, go ahead and just round mathematically, okay? Now, but remember, just like we talked about with drugs and stuff, it is going to be patient dependent. Like if this were a cardiac guy, I'd probably go, well, I'm going to go down anyways, 26. But if this was like 26.84, I'd probably still just do 26 because it's a cardio kid, right? So my actual answer is 26 milliliters per hour. Make sure you have this, you write this down before you do your rounding, because I want to see how you rounded, right? Okay, cool. So now this is my pump rate. Got my answer for my pump rate. Excellent. Now, oh my God, the pump is broken. There was an earthquake. Something happened, and now we need to get a drip rate. Okay. Need, have. What is the unit for drip rate? Let's go. Let's look at my notes. Let's look at my notes. That's right. It's drops per second. Okay, so I got to get all the way down to drops per second. GTT per second. And what do I have? Well, I have 26 milliliters per hour. Do I need any of that other information? Well, I don't need any of this. I don't need any of this information right here, right? So remember, with dimensional analysis, it's going to tell you, right? So if you don't know if you need anything else, just get started and you'll figure it out. So I'm just going to start with what I have. And then if I'm missing a puzzle piece, I'll figure out that I am. So I'm going to start with my 26 milliliters per hour. Okay. I need, so I look over here at what I need, and it's like, okay, GTT, I don't have anything to link it to yet. Seconds, though, seconds and hours, those have a relationship. So let's do that. How can I link hours to seconds?
3,600 seconds in an hour.
There are 3,600 seconds in an hour. If you don't already have that memorized, do not worry about trying to memorize it, though. What's the in-between of hour and second?
Minutes.
Minutes, right? Great. So how many minutes are in an hour?
60.
Awesome. Yeah, so we can use that one, right? So I put my hour on top and I go 60 minutes. Again, if you want to go straight to hour and 3,600 seconds, you can. I just don't want to give you extra stuff to memorize. But I know you know how many minutes are in an hour, so you should be good there. But minutes aren't what I want. I want to get rid of minutes. I just want seconds. I'm going to do 60 seconds. And now let's see. I don't know. Am I done? I don't know. Let's find out. Let's cancel. I've used all my pieces, so maybe I'm done. Hours go away. Minutes go away. I have milliliters over seconds. Is that what I need? No. Huh. Well, crap. Okay. What information do I have or need that will link up drops and milliliters? Because I have to get rid of these milliliters. Any ideas?
Would it be whether you can use a standard or a micro drip, depending on the weight of the animal?
Exactly. So, and I don't think I wrote that in the notes, so let's make sure we put that as information we need to know. For our drip rate, we need to know micro or standard line. And make sure you know what each of those are, right? So micro is going to be 60 drops to make a milliliter, and standard is going to be 15 drops to make a milliliter. I meant to tell you guys to always check your line in practice, because there is actually another standard or macro. It's 10 GTTs per milliliter, and you'll see that in large animal, and then you may see it in shelter too, because they're cheaper. So good. So what's my rule? This patient is 14 pounds. Okay, patient's 14 pounds. So which line am I going to use? A micro or a standard? You guys remember the rule from the PowerPoint?
You're going to use a micro because it's under 20 pounds.
Exactly. So remember, it's 20 pounds that we're looking for here. So again, if I wanted to put it in my notes, I would say less than 20 pounds or greater than to equal to 20 pounds. Right. So I want to use the micro. So the missing puzzle piece I didn't have, because it's not going to be in your information up here, right? It's one of those things you just have to know, is this guy, 60 GTT per milliliter. So let's put that guy in.
And sorry, Miss Stephanie, it's either the 60 or the 15, is that correct? Or is it always the 60?
It's weight dependent, right? So it depends on your patient. So yeah, so right here, I would make sure I have that in like on a flashcard or notes, right? So if the patient is under 20 pounds, I use a micro line, and a micro line is the 60 drops per milliliter. Yep. If the patient's greater than or equal to 20, I'm going to use a standard, and the standard is 15 drops. And so this guy is 14 pounds, so I know I need to use a micro.
Okay.
So yeah, you're going to have to figure out which one to use.
My nose and missed it.
No, you're fine. You're fine. Yeah, sometimes people think it's whichever one you have in clinic, which honestly, that may be true if you're running low on supplies or you're working shelter med. It's not that you can't use a micro on a big dog or a macro on a small dog. It's just, it's going to be so hard to count, right? Because on a big dog with a micro, oh my gosh, you're going to be counting like 20 drops a second or something. It's going to have to go so fast. And then vice versa. On a little animal, if you had to use a macro line or a standard line, it might be like 1 drop per 10 seconds, which is so slow you might not even be able to get it to go that slow.
It's funny though, because I think in clinic we only have one size.
Yeah. So thank you for bringing that up. Most clinics only have standard lines. And the reason why they only have standard lines is because sub-Q fluids are very common, and you never want to use a micro on sub-Q fluids because it takes forever, right? When we're given sub-Q fluids, we normally want to go as fast as possible. Yeah, most places only have standards. If they have micro, they have a couple of them way in the back for if they happen to. The other reason why most places don't worry about it is because you should always ideally put the appropriate line on your bag, but it doesn't actually matter for the pump. The pump can figure it out. It doesn't matter what line you have on the bag. If you set your pump to, what was our rate? 26 milliliters an hour. It doesn't matter if you have a micro or a macro line on that bag, because the pump is going to make it work, and it has a special sensor to know how much fluid is moving through it, right? So, and most clinics are always using pumps, so that's why it's not considered like a huge deal. But if you ever worked somewhere where they didn't have pumps, then that'd be something to consider. If you worked at exotics, you'd probably end up having more micros than macros, I would imagine, because all those guys are pretty small. But Dr. K only had 60 GTTs at her clinic. All right, so let's see if we're done now. So now I have effectively gotten rid of my milliliters, and all I have left are drops. So I have drops over seconds. Hooray. So let's calculate the top. We've got 26 times 60 equals 1560. Don't forget your unit. And then my bottom is always going to be 3,600 seconds. Okay, and then we take 1560 and we divide it by 3,600. Oof, and we get 0.43 repeating. Here's the thing. When you're doing your drip rate, I want you to keep minimum 4 decimal places, okay? The 10,000 spot. And that's because we're talking about drops, right? We're talking about itsy bitsy little drops. So to round too early on a drop actually can be a significant amount, right? Like half of a drop is actually a lot when we're talking in terms of drops, right? So you really want to keep your numbers out until we do get to the point where we can round. So my answer right now is 0.4333 drops per second. Okay, so now I need to get this to a countable rate. All right, I need to be able to count this. I can't count 0.433 of a drop. So how do I do that? For note's sake, I'll write this. You don't have to write this. Okay, we're going to start multiplying this number. We're just going to go times 2, times 3, times 4, times 5. And these are seconds, right? Because this is the number in your calculator. And I'm like, well, that's in 1 second. Well, how many drops are in 2 seconds? How many drops are in 3 seconds? How many drops are in 4 seconds? Until we get to the point where we can round the number, okay? Now, there's a rule for when can I round. And the rule goes like this. If I have 0.9258, or if I have 1.0629. Okay, so This is after you've started multiplying in your calculator. And we're going to do this one in a second to work through it. I just want to show you the rule first. All right. So when you take this number and you multiply it by 2, you're going to ask yourself about the answer you get. Okay. You're going to look right here. Oh, you know what? Let me write it out in word terms. There's an actual definition like word. So you can round no more than a tenth. Okay? We need a whole number. But, okay? So we can't round more than a tenth. So for instance, for this one right here, well, obviously I'm not gonna, it's a 4, it's not over 5, so I wouldn't round to 0, right? That makes no sense. But I couldn't just round up to 1 either. That's crazy. That's double. That's more than double what that is. That's a lot, right? So I can't do that. So I need to get to the point where I'm only a tenth away. Okay. So what that looks like is, so when you get the number in your calculator for each time you do this, and once you get the hang of it, it goes fairly quickly. You're just going to look at these 2 spaces right here. Okay. If the number right here is greater than or equal to 90, you're going to round up. Go ahead and round up and make it 1 or 2 or 3, whatever this number is, right? Round it up, or up from that number. If I look here and it is less than or equal to 10, so this is 6, right? I'm going to round down, all right? So if I take that rule to these numbers I have here, this would end up equaling 1 drop. And then the seconds is however many times you multiplied it by, and we'll get to that, right? So this I could round up to 1 drop. And then this one, because I have 6, which is less than 10, I'm going to round down. So this also would equal 1 drop. Okay? So let's go through it. Let's do it. Let's make sure I still have the number in my thing. I'm going to write out each time I multiply it for you so that you can see it. You do not need to do that on the homework or on the test or in practicum. All you have to do is you have to show the last one that you get, right? So let's say it ends up being times 5, and you get like 1.095, whatever, right? You would write times 5 equals and write out the long number, 4 decimal spaces, but then give the actual answer, equals, and give the rounded number. So I'm going to show you guys that. So my number is 0.4333 drops. The whole thing is drops per second, but I'm going to multiply by my seconds. So let's do times 2, and let's see what we get. Oh, no, my thing turned off. So if I do it times 2, I get 0.8667. My 8's repeating, right? So I'm going to look here. Okay. This does not make the rule, right? So I can't round yet. So I'm not done. Because, right, this is not greater than or equal to 90, and it is not less than or equal to 10. So I'm not there. A little trick when you're putting this in your calculator over and over again, I recommend after you multiply by the number, go ahead and divide by the same number. It'll take you back to the original number without you having to retype it in every time. So now I'm going to go divided by 2. It also helps you remember what number you're on, because students will forget that sometimes. Not just students. I do it all the time. Color. Let's do times 3. I just got 1.3. If there are no more decimal places, you don't have to make them up. Fine. So again, I'm going to look here. This is technically 30, right? So nope, I can't round yet. Okay. So in my calculator, I'm going to divide by 3 so that I can get back. So you can see once you get the swing of this, you'd be going really fast, especially because you don't have to write every time. I don't go too fast. Sometimes you can overshoot it. I've seen that happen too. So let's do times 4. See what happens there. I have a feeling this is going to take forever. It's going to be an ugly one. 1.733 repeating. Again, I look here. Nope, I'm not done yet. Okay, so I'm going to divide by 4. I'm going to times by 5. Oh, man, so close. No tomato. 2.1667. Man, So close. But that's 16, right? 16 is not less than 10. It's not greater than, so nope. All right. Let's divide by 5. Let's times it by 6. Oh, man. This is a long one. I picked the ugly one they gave us. 2.6. Again, nope. I'm just going to keep going. Divide by 7. I think we're almost there. Oh, no. There it is. I knew we were almost there. Times 7, I get 3.0333. All right. Okay. I look here. I'm less than 10. So I'm going to round down. Now remember, round down doesn't mean I change this number. It just means I don't round it up, right? And I'm not going to go to 2. I'm just going to leave it at 3. Okay. So this equals 3 drops. Remember, the number in your calculator is the drops, and then this number is your seconds. That's another thing students do is they'll just write 3 drops per second. No, that's not right at all, right? So remember, it's the number you multiply by. You are multiplying by seconds. So it's 3 drops per 7 seconds, and that's going to be an annoying one to count a little bit, honestly. All right, how do we feel about that? Then I would go like this. That's my answer. So that's my answer. So now I have a total volume for the day for my patient. I have a pump rate that I can set them up on, and I have a drip rate that I can actually count. Okay. All right. So that's what you guys are going to be doing in the homework packet. I do have it due. I have it due Sunday by end of day, which means midnight, right? And the reason for that is because I would like to be able to look through them and give you guys feedback before your quiz on Monday, because you're going to have a problem on Monday to do. So I want to make sure that you have some feedback for that. So yeah, so get those to me then, and then I'm going to try to grade them as they come in, so I don't have a whole load to grade, and give you guys some feedback and some notes. And remember, it doesn't matter which number within the range you pick, as long as you pick the right one. If you end up picking the wrong range, I'll still grade you like on the math for the rest of it. So it wouldn't be wrong entirely. But you got to be careful, because you mess up a little bit on here, and you do end up being wrong in some other areas. Okay. Any questions before we move on? Nope, we're all good. Okay, excellent. So the other PowerPoints are already up. We're going to go ahead and look through this. We're going to kind of breeze through a little bit this IV catheter. You guys should have watched the videos already. We're going to watch a video together. We're going to watch a Dove Lewis. We'll go through the PowerPoint, and then we'll take a little break before we do the video. So that'll give you time to get the notes sheet. So on Blackboard, you know what? I need to pause this lecture because that was fluid lecture. So I can end it and we can move on.